Okay, this is one of my favorite problems because it's a really good problem because it shows you you need to really understand the math behind physics equations. If you understand how the ratios are, how the variables are related to each other, it can be really helpful. So in this one, it says before we're just using the pendulum equations, all we're doing here, but this seems like this could be confusing to people. It says before blast off, a Venusian, a person on Venus, measures the period of a pendulum at 2.30 seconds. Now that's all we know. It doesn't say what's the length of the pendulum, and it doesn't tell us what gravity on Venus is. If we knew gravity on Venus, we could solve for the length of the pendulum. Or if we knew the length of the pendulum, we could solve for gravity on Venus, but we don't. We just know that before blast off, 2.30 seconds is the period of the pendulum. During blast off, she measures it again, and this time it measures a lot less time, 0.939 seconds. And the reason for that would be because during blast off you're accelerating, so it's going to seem like, how you get thrown back into your seat. It's going to seem like that you're under more gravity. It's kind of simulated gravity, right? So the period of the pendulum is going to be shorter. Okay, so we're wanting to know how many g-forces is she experiencing, which basically means take the gravity the simulated gravity she's experiencing in the second experiment, the gravity, and then we have to divide it by whatever the gravity is on Venus. Okay. So how do we do this? Well, if I just let you do it on your own, I think you could probably figure it out. What you might do is you might just throw in some length for the meter. I mean, that's for the pendulum, because you could do that because she's using the exact same pendulum. So you could just throw in like 1 meter for the length, and so I could do like before the experiment, like period 1. Should equal 2 pi times the square root of the length of the pendulum, and we'll just say it's 1. So I could do 1 over g, that we'll call that gravity 1. That gravity 1 is actually the gravity of Venus right there. And I could put in the period and solve for this gravity and just assume that that's the gravity on Venus. I wouldn't know that for sure because I just assumed a 1 meter length pendulum. Maybe it's something else, so the gravity could be something different. But I could do that, and I could get some gravity that we'd say is for the first thing. Okay. Now what I want to do here is I want to square this thing, so I get T1 squared equals 4 pi squared times, I guess, 1, we'll say, over G1. Okay, now the length was going to stay the same every time. That's why I put a 1 in for it. This 4 pi squared is going to be in here in both equations. So really what I want to look at is I want to see that the period, the first period squared is proportional to 1 over the gravity. Okay? So if I do this equation again, like while we're blasting off, I'm going to get, I have a different period, okay? And that squared would be proportional to 1 over the whatever gravity it's simulated there, okay? So this is important to just see the ratios here. And what I can do then is I could just, these are inverses of each other. So what I could do is I could say if I put gravity 2 on the top and gravity 1 on the bottom, okay? And that's what I'd want to do, because this would be my g-force, right? The gravity 2 is the simulated gravity divided by the gravity 1, which is like the gravity on Venus. So this ratio will give me my g-force. Now, what is that equal to? Well, remember, they're inverses. So if I put gravity 2 up here on the top, I would have to put the period 2 squared on the bottom. Gravity 1 is here on the bottom. Over here, I need to have period 1 squared. Okay? And what I end up getting here is if I take period 1 and divide it by period 2, and then square that. So that's the same thing as this right here, right? Period 1 divided by period 2 and square it, that actually is my g-force. That's my g-force. because that would be gravity 2 over gravity 1. Do you see that or not? I like this problem because it's, a lot of you would solve it by, you'd put in like something for the length. You would have figured out what this gravity is, and then you do it again for the other one, figure out what the new gravity would be, and then take that gravity divided by gravity 1. You would have done all that, but really all we need is this ratio here. All we need to do is take period 1, divide it by period 2, and square it, and that's going to be your g-force. So the first period 1, was 2.30. We're going to divide it by 0.939, and we're going to square that. I'll do that real quick. 2.30 divided by 0.939, and square it, and I get 6 G's, 6 G forces. Okay, which is okay. I think she can live through that blast off, I believe. I can't remember what point you pass out, how many G's you experience before you pass out or not, so someone can look that up.